Hi, thank you for joining us. I'm Kelly Dack for Real Time with IPC, out here on the show floor in the Real Time booth. And joining me today is Mr. John Coonrod, Marketing and Development Engineer over at Rogers. Welcome, John.
Thank you.
Hey, thanks for being with us.
My
And
pleasure.
I understand you've got a paper presentation coming up,
Right.
and you're going to be talking about high-frequency laminates.
Correct.
From Rogers.
Right.
Now, from what I understand, Rogers is getting into quite a few different types of laminates that aren't the traditional polyimides anymore.
Right.
Tell us about it. Tell us about your paper.
Sure.
And maybe give us a little more Microwaves 101. How about that?
Be happy to.
Okay.
Yeah, actually the paper I'm presenting will be insertion loss of different configurations used in the printed circuit board industry for high frequency applications. And the paper is really meant to be more a Microwaves 101, a kind of an overview of different comparisons of the most three common configurations that we run into. And the configurations are microstrip, coplanar, and strip line, and it's really a comparison of how one configuration has a little different losses than the other. And I give comparisons and also why you may pick one configuration over the other.
Yeah. Well, what are the ramifications of losses? I mean, what
Right.
can happen?
Yeah, I guess the simplest way to think about it is if you have something that's battery operated using materials, the insertion loss will cause the battery to drain faster. So that's the obvious one. Many other considerations come into play with insertion loss, where at very wide band applications where you have a wide frequency range, sometimes you can have problems where the signal doesn't perform the same at different frequencies because of loss, that you have more loss at a higher frequency than you do at a lower loss, so it actually disturbs the pulses at different frequency ranges. So there's actually a pretty good list of things that insertion loss does affect.
Okay. Well, with your laminates now, are you getting more questions or offering wise counsel to more of the design community or the manufacturing community?
Right. Yeah, actually, we get a fair amount of inquiries from both the OEMs and the circuit fabricator as well. The OEMs are interested typically in the electrical properties of our laminates, such as dielectric constant, dissipation factor, and they're also interested in whatever insertion loss information that we have. The fabricators many times are interested in the fabrication aspects of the circuit using these materials, but also how the circuit fabrication could impact the insertion loss and other performance of the circuit itself.
Okay. And maybe we can talk a little bit about stack up and impedance control.
Right.
Lots of variations of materials.
Right.
Tell us about some of those.
Yeah, sure.
And some of the challenges that there are in stacking up some of these
Right.
circuits.
Yeah, so the three configurations I'm going to talk about in my paper is two of them are double-sided, so they're two copper layer circuits, a microstrip and a coplanar, and the third one is a strip line, which is a three copper layer circuit. And that one you have a little bit more questions about the fabrication, where you have a bond ply or some kind of bonding materials, and then you have questions about possibly the interaction between a bonding material and a laminate. So Rogers offers multiple different laminates that have different dielectric constants, so you can achieve different impedance values. We also offer different bonding materials and different prepregs, so that are friendly to the laminates, so you can build up quite a range of configurations and multi-layers.
Okay, and some of the ranges of frequencies you're seeing, what's common out there?
Yeah, it's I guess the most common range would probably be around 700 megahertz up to maybe 24 gigahertz, and we have several applications at 77 gigahertz. We have a few applications at 110 gigahertz, so our materials are used across a very wide range of frequencies and applications.
Okay, well, very good. Wish you well on the show here. It's the
Thank you.
first day, and we just got started.
Yep,
So
exactly.
Thanks for being with us. With me has been John Coonrod, Marketing Development Engineer over at Rogers. I'm Kelly Dack for Real Time with IPC. Thanks for being with us.